Okay, let's get started. I'm Liz Hill, Business Development at Formlabs. Thank you so much for joining us. So welcome to today's session, Rhino for Jewelry. Today's tutorial will be hosted by Debbie Green. Debbie is a jewelry designer and 3D artist who has worked with 3D technology for over 10 years. After receiving both gemology and applied jewelry arts degrees from GIA, she began her career in New York City as a jewelry designer and spent 7 years at Temple St. Clair before moving on to broaden her career into fashion. On a personal note, I just wanted to say that I'm really excited to have Debbie here with us. I had the pleasure of working alongside her during my time at Coach and have always really admired her talent and ability to pick up 3D softwares very quickly. So you guys are in for a real treat. If you are new to our Formlabs Comes to You series, definitely be sure to check out our full month of jewelry offerings during the month of June, which has really just gotten underway. So last week we did a blender for jewelry demo with our Formlabs lead for jewelry, Amos. And then next week I will actually be doing a Tinkercad for jewelry demo, which will be a really entry level perspective into jewelry design using CAD. So if you're a new CAD user, have never looked at 3D modeling at all, this is a great one for you. And then definitely stay tuned for additional announcements for more jewelry modeling demos, as well as a panel discussion at the end of June with our friends over at Rio Grande and GIA, where we'll discuss jewelry education as well as professional workflows. And there'll be a lot of tips on how to get started there. And before I hand it over to Debbie, just a quick reminder that we will have time for a Q&A after Debbie's demo. So definitely feel free to submit questions as we go, save them for the end. It's totally up to you. If you do want to submit questions throughout or at the end, be sure to use the Q&A button at the bottom center of your screen. Don't use the chat just because we're not monitoring that for questions. So be sure to drop them in the Q&A. And then just one quick heads up, Debbie does not have video going right now. She'll have her screen shared. So you will hear her, but you will not see her. Just wanted to let you know in case there's any confusion there. So with that, I think I'm gonna just sign off here. I'll meet you guys back for Q&A at the end. And Debbie, the floor is all yours. So take it away.
Thank you, Liz, for that introduction. Hi, everyone. Welcome to Jewelry Prototyping in Rhinoceros. I know many of you are new to 3D, so today I'm going to share with you a broad overview of what Rhino is and how it works, a few benefits that I believe it has, and then I'm going to demo how to make a simple ring with Rhino and T-splines to give you a better idea of what can be done within the software. First, a little bit about me. I got started in 3D in 2008 when I went to the Gemological Institute of America in California. I'm actually a 5th generation jeweler. My grandfathers and both of my parents went to the GIA. So I followed suit after undergrad, not really knowing what I wanted to do with that degree, but I really ended up enjoying the design aspect and I made a career out of it. At the GIA, I took both the graduate gemologist program and a design program, which allowed me to take 2 months of a jewelry CAD software called Matrix. Matrix is a very powerful jewelry tool that was actually built within Rhinoceros, and it's quite expensive compared to Rhino alone. So while I learned it at school, I ended up using Rhino by itself in my professional life. As Liz mentioned, I've been working in various capacities within the jewelry and fashion industries for over 10 years, and a lot of that time has been spent prototyping in Rhino. So I'm excited to share with you some of the knowledge that I've gained along the way in 3D so that you could possibly integrate it into your own workflow. So let's talk about where 3D can fit into your design workflow. In my workflow, I have 4 general steps to creating a finished piece of jewelry: concept design, 3D development, prototyping, and manufacturing. Every designer's process may be a little different, but generally when I'm developing a new piece, I begin with concept design. Concept design for me means sketching and gathering references, but for some other people, concept design could be straight in 3D. If you do start with a sketch, in 3D you can bring in your reference image and begin building off of that. If I'm working with a client, I send either screenshots or photorealistic renderings of my 3D model for approval in order to move on to the next phase, which is prototyping. Depending on your workflow or your partners in manufacturing and how they work, prototyping can mean a few different things. Prototyping can mean 3D printing your model, or it could also mean a hand-carved wax of your design based on your model, which is what you see here. I've marked the arrows going both ways for the first two phases because oftentimes this workflow isn't completely linear. You may get callouts and you need to go back to the concept design or back into your 3D model and make modifications. This is very common, but of course the goal is to have as few back and forths as possible. Adding 3D into the mix really enhances the visuals and information provided to both the client and the manufacturer and helps you get to that last phase, a manufactured piece that can be sold or worn, whatever your end goal is. Benefits. Just want to highlight a few benefits that I think are really important for Rhino with jewelry. First, we have quicker decision making. As many of you know, there are a lot of small details that need to be worked out when creating a piece of jewelry. Details like junctions or transitions or stone sizes, those are all elements of designs that may not be fleshed out during your concept phase and may affect the end look of your piece. When you're creating in 3D, all of those details are worked out. You're looking at a fully visualized representation of your design and can make almost instant design calls and modifications as you build your 3D model. Next, we have clear design intent. When you send a 2D design to a factory, inevitably there will be some interpretation involved. You don't need to rely on anyone interpreting correctly if you have a 3D file. What you want your piece to look like from every angle has already been thought through. Quicker development time. When there are fewer details or detailed questions to be worked out at the manufacturer level, it will mean you've cut down the time needed for development with that jeweler or that factory. Providing the clear design intent means less iterations and you can get to an approved final version of your piece in less time. Another great benefit is that 3D is very cost effective. As they say, time is money. Less iterations mean less cost of materials and less labor. And finally, we have early cost analysis. Sometimes when you're designing jewelry, you're working within a budget. Developing in 3D means that you can determine exact stone sizes and quantities. You can even analyze metal weights and materials so that you can determine the price of your piece before any other work is done. And that aspect can be essential to saving on lost costs and wasted efforts for a piece that's not within your budget. So there are really two main functions for 3D models in jewelry, and depending on that function, you're going to need to make modifications to your file. It's manufacturing and visualization. The main differences of these files generally involve stones. A file for manufacture will have higher prongs or higher beads to allow for setting and polishing. If you have bezels, the bezels won't be bent over the stones to hold them in, and there may not even be stones within your file. Things like fillets, which are the roundness of the edges that comes generally from the polishing phase, those details may be left out. The file that you create for rendering, on the other hand, is to visualize your end result. When you show a final design to a customer, you want to present a finished looking piece. And in that respect, the prongs and the edges, they'll be polished down and the stones will look like they're set. So just keep that in mind when you're beginning a new project. Ask yourself, what is your objective? So let's get into Rhino a little bit. There's a lot of 3D software out there, and you'll find that a lot of them work very similarly. I primarily use two programs. I use Rhinoceros or Rhino, and I use T-splines. Rhino models NURBS surfaces. NURBS modeling is often found in industries where form and function are important. So think aerospace and architecture, and of course, jewelry. I find working in Rhino allows you to have a great degree of flexibility in your designs while still maintaining the precision modeling needed for prototyping and manufacturing in the jewelry industry. As many of you know, jewelry expression is really limitless, but jewelry is also very small. So when you're working with minimum tolerances for wall thickness in metal or when you're setting stones, it's really important to have precision. There are other NURB software out there that offer you that level of precision. SolidWorks is one of them, but what sets Rhino apart is its flexibility. Other programs are usually very structured. You start with a solid object and then you sort of cut away at it to get your desired shape. With Rhino, you can really start anywhere. How you want to build your design is completely up to you. And then lastly, Rhino allows you to tailor how you work in the program by adding features called plugins. There are hundreds of different plugins for Rhino that you can download to enhance your modeling experience. These can be industry specific, like Matrix, which I spoke about earlier, or it just can be a general modeling tool, which is what T-Splines is, and I'm going to talk about that in a little bit. So how do you model in Rhino? Well, there are three main entities that you work with in Rhino, and understanding the differences between them is essential to understanding how you model in Rhino. So you have curves, surfaces, and solids. Curves are fundamental to building anything in Rhino. Think of curves like pencil strokes. They're used to draw and define shapes. The information that Rhino receives from curves affects how it builds a surface and ultimately a solid. So from your curves, you create a surface, you can see in the second image. A surface has no thickness, but you can join them together to create multiple surfaces, also called a polysurface. So whereas curves are the building blocks to surfaces, surfaces are the building blocks to solids. A solid is essentially a closed polysurface. So if you see on the right in the bottom corner, I have an image of the solid above, but I've taken away a few of its surfaces. They're missing. This is an open polysurface because it doesn't enclose volume. If you're building in 3D for printing or for manufacture, you'll learn very quickly the importance of solids because you cannot print an open polysurface, you need to print a solid. T-Splines. As I said earlier, T-Splines is a plugin for Rhino. T-Splines allows you to perform a different type of modeling within Rhino. It's called subdivision or polygonal modeling. Whereas Rhino creates NURB surfaces, these are mesh surfaces. There are some very popular sub-D modeling out there where sub-D is the primary form of modeling, such as Maya or Modo. And the reason that they're so popular is it's often used in character building for video games or for special effects. And it allows you to build something very organic with a lot of control. Where Rhino might be used in jewelry for things like ring shanks or stone settings, I use T-Splines to help create my organic, complex shapes, anything that might have a complex connection point that I want to be smooth. Shapes like this are possible in Rhino alone, but you can really achieve them in a fraction of the time with polygonal modeling. And on a personal note, I find it much easier to explore my designs and play with shape variations in T-Splines because modifying it is a lot quicker for me than in Rhino alone. A quick aside, T-Splines is no longer available for purchase for Rhino. It was integrated into a software called Fusion 360, but there are plenty of other sub-D plugins available, and any of the principles that you see here today about sub-D or polygonal modeling can be applied to any of those software. So I want to explain the difference between interacting with a Rhino surface and with a T-Spline surface. If I wanted to interact with a Rhino surface, I would need to basically affect the curves that I use to create it. So on the left here, you can see a gray Rhino surface, and on the right is a blue T-spline surface. If I wanted to modify the Rhino surface, it's essentially as a unit. I could move it around as a unit, I could scale it, I could rotate it, but I would need to split it up in order to modify its shape. With T-splines, I can modify the elements that create it. So I could modify its faces, which you see here are being highlighted. I can modify its edges, or I can modify its vertices, which are the junctions of the edges. And I can do that the same way that I would modify the Rhino pipe, but just with that one element. So I can rotate them, I could scale them, or I could translate or move them. So you see I have a high degree of control when I'm modifying my T-splines. You can be very targeted in your modifications to a sub-D model without a lot of extra steps. And that's why it's very useful for models that are more free-form or organic. So let's get started modeling. We're going to be modeling this butterfly ring. I'm going to model the shank in Rhino. So I'm going to use curves and show you how that's done. And then I'll model the butterfly in T-splines so that you can see how that's important for an organic shape that you might want to explore your design with. So let's get out of this and into Rhino. So a few things before we get started, I just want to explain. There are 3 different ways that you can initiate a command in Rhino. You can do it over here with these buttons. If you extend, there are further buttons inside, and if you hover over, right and left click mean different things. The same commands are up at the top. They're just separated by categories, so all the curves are in here, surface, etc. And then you can initiate a command with the command bar by typing. So if you know what your command is, you can just start typing. There is no right way to initiate a command. Just know that I do all 3. I mainly type, but I do find buttons sometimes or go up to the top. Really, however you want to do it is fine. And then the other thing that I want to mention is that it's really important to maintain an organized, structured layer tree. So you see over here, I've already created a new layer for each entity that we will be using. And this will be really helpful when we need to go back and reference something from earlier, or if later we need to make modifications to something. It's not all in the same space, it's very organized, and I'm not going to lose any of my information. All right, so let's get started. So first, what we need is a finger hole. We're creating a ring, so we need to get a circle. A standard size 7 ring is 17.3 millimeters in diameter, so we're gonna get a circle that size. I'm gonna come over here to circle, and one thing that Rhino is really helpful with for beginners is that Rhino actually prompts you. It asks you questions in order to complete the command. So if ever you're stuck and you don't know what to do next, all you have to do is come up to the command bar and look and see what it's asking you. So in this instance, it's asking me, where do you want the center of your circle? Well, I want the center of my circle to be at the origin, so I'm just gonna hit 0 and hit enter. And now it's asking me, what do you want your diameter to be? Well, if I didn't need it to be parametric, I could just pull out to whatever size I thought looked great, but I do know I need it to be 17.3 millimeters, so I'm going to type that and hit enter. Now we only need the bottom portion of this finger hole at the moment, so I'm going to split it with the command split. And I'm going to split it, this is my object I would like to split, and I'm going to split it with a point. So I'm going to come over here, oh, my snaps are off. I'm going to get a mid snap and an end snap and hit enter. And now you see I have 2 separate curves. So I'm just going to lock this top portion because I don't need it right now. So now what I need to do is I need to tell Rhino what I want the shape of my ring to look like. Do I want it to be square? Do I want it to be round? I'm basically going to build cross sections of my shank and allow Rhino to flow it along this finger hole. So I'm going to build my profile. What this time around, I think I want the inside of my ring to be flat, and I would like the outside to be a little round. So I'm going to build a profile that looks like that. I'm going to come over here to my line, and I'm going to make sure that I'm at the end of my finger hole and click. Now I know that I want a 2 millimeter wide profile at this point, so I'm going to hit 1 because it's 1 in each direction. And I'm going to hit shift to make sure that it's straight and click. Now I need the curved portion, so I'm going to get a curve. So it's asking, where do you want the center of your arc to be? Well, I want to make sure it's at the center of my line, and then it's going to start at the end of my line and end at the other end. Now this is a little too shallow for me. I would like my profile to be a little bit taller. So I'm going to use my gumball and I'm going to parametrically move it out. So I'm going to double click on this red arrow and hit 0.5. So now I need to connect my 2 curves. So I'm going to come up here to curve, extend curve by line, and just make sure that my 2 curves meet. So you see I still have 2 separate curves. So I'm going to join them together so you can see it says 1 closed curve at the top. Now the last thing I need to do is a little too sharp here. This model is for visualization, so I want to add all of those fillets in, all that polish, those polished edges. So I'm going to fill it. I'm going to use the command fill it, and I want to change my radius to 0.3 millimeters. So I'm going to select the two parts of my curve, and you see I've filleted, I've rounded out that corner. Now, another great feature of Rhino is that it allows you to save time by right-clicking, and you can initiate the last command that you just did. So I've just done that, and I'm just going to fillet this other edge. Okay, great. So now we have our profile curve. Well, our shank is actually going to taper. So it's going to be this size at the midpoint, and then it's going to get larger at the bottom and taper to the same size at the other end. So I'm going to take my profile and I'm going to mirror it or copy it to the other side to make sure that it tapers to that same size. So I'm going to hit mirror and mirror it onto the other side of my finger hole. So I've already created the larger portion. I did it the same way that I've shown you the smaller one, just in the interest of time. So now let's get going creating our shank. I'm going to get onto the right layer, which is our shank poly surface. And I'm going to use a command called sweep 1. So Rhino's asking, what rail do you want? Well, I want the rail to be our finger hole. And then what are your cross sections? Going to select our cross sections. Now I could have gone counterclockwise or clockwise, either way, doesn't matter, just as long as you are selecting them one after the other. I'm going to hit enter. And the last thing I need to do is I need to adjust my seams to make sure that they're all hitting my profile in the same spot. I usually just move them over to where they intersect with the rail just so that I know that they're in the right spot. And then you just need to make sure that your arrows are pointing the right way. Now they are. Hit enter. Here are some other modifications that you could make, but I don't need any of those. I like what my shank looks like. And now you see I have an open poly surface or open surface that is my shank. So now what I need to do is I need to start building my butterfly. I'm gonna turn on this reference image. It's just a rough sketch that I made, and I've already pulled it in and scaled it and placed it where I want to go. Those are things that you would have had to do if you were starting from scratch. But I want to start tracing over my butterfly. So I'm going to use a control point curve and just start tracing. So I'm going to click everywhere where the shape sort of changes. So just keep clicking. And then you just want to make sure that you're closing it up, so you make sure that you get a point snap and you close up your curve. Now, if I didn't like this, I could certainly start over, or I could, just lock that, turn on my control points and move my points so that it fits the shape that I want it to be. So I'm going to need to do this for the outside of my wing and the inside on both sides. I've actually already done that. So you see I've created a curve on the outside and inside for this wing, and the same on the other side. I made a couple modifications based on my drawing. So now we need to create a surface from these curves. There are a couple ways that I can do that, but I'm going to turn this surface into a T-splines, because when I put it on my ring, I want to be able to modify it. I might not like the shape of it when it's up, once it's up there, so I want it to be a T-splines. So in order for that to happen, I'm going to use a command called sweep 2, which is very similar to how we made our shank, but that way I can turn it into a T-splines. So I'm going to use the command sweep 2. Let me just turn off my reference image. So what is my first rail? This is my first rail. This is my second rail. And this line here is my cross section. I'm gonna hit enter. Now, everything that it's created here, all of these lines, they're called isocurves. And it's basically just information that is telling Rhino how the surface needs to look. Because I'm turning it into a T-splines, I want to make sure that I'm very targeted in where my isocurves are and the direction that they're going. So I'm going to come over here to add slash, and I'm just going to start straightening it out a little bit. So I'm going to click on one end and the other, and I just want to make sure that anywhere where my isocurves are a little angled, they become a little straighter. So right here, it actually folded over itself, which would not be good. So I'm going to straighten that out. I'm going to straighten it out here and here. Okay, so now it looks okay. Hit enter and hit okay. So if you see from the perspective view, it's just a surface right now. It really has no dimension, but I'm going to turn it into a T-splines and then give it dimension after. So the next thing that I need to do is I need to rebuild. I rebuild a lot when I'm modeling. I think it's really essential to keeping your curves and your surfaces simple and even. And this step will really be helpful when you're doing more complex commands like filleting edges or blending surfaces or booleaning. If you rebuild, then you'll really have a lot easier time doing that. So I'm going to select my surface and hit rebuild. Now I can designate how many points I want going each direction. These points are fine. I think 30 will get me to where I want to go, and 4 is fine for the V direction. And I'm going to hit enter. Now you can see it actually changed the shape a little bit because Rhino essentially lost information of how that shape is going to go. But because I am turning it into a T-splines, I'm okay with this. So I'm going to hit TS convert, and that's going to turn it into a T-splines. Anytime that there's a TS before your command, you'll know that it's a T-splines command. Now I know that this is a T-splines command because if I come over and enable T-splines, you can see I now have faces, I have edges, and I have vertices. Now those inside vertices are not something that I want. They're tangency handles, and I'm just going to delete them. I'm going to come up here to tangency handle and select all tangency handles and delete. That didn't work. Let me try one more time. Select all tangency handles and delete. So now what I can do is I can just start modifying my T-splines. I can take my translate and I can start pulling on my vertices or pulling on my edges to make it look the shape that I want it to look. I can even, come over and add an edge if I want. So I'm going to double click on this edge and I'm going to hit TS insert edge and add an edge here. So I've actually already done this. I'm going to hit show to show you. This is my T-splines edge. I've made it so my T-spline surface. I've made it so all the edges are where I want them to be. I've also added a few faces coming out here, and that's really going to help with connecting my butterfly onto my shank at a later time. So I have it for this side and I have it for this side. So now what I need to do is it's flat right now. It's a planar, and I need to put it on my ring. And I'm going to do that with the command called flow along surface. So what I need is I need two surfaces. I need a surface that's flat, that is the same plane as my butterfly wings, and I need a plane that is, or a surface that is where I want it to go, and that's going to be the top of my ring. So I actually got this surface from this top portion of my finger hole that we locked earlier. I created a surface out of it already to save time. So the command is flow along surface. It's asking what objects do you want to flow? Well, I want to flow my butterfly. So I'm going to make sure that I grab my butterfly. I don't know why this isn't working. Oh, it's because T-splines is on. Let me try again. Flow along surface. Objects I want to flow. It's my T-splines. Now you're going to get this little dotted yellow cage, and that's a good thing. That means that it's keeping it a T-splines. If you didn't get that cage, then it would actually be turning it into a Rhino surface and you wouldn't be able to modify it after. So we're happy with this cage. Now it's asking, what's your base surface? Well, the base surface is my green flat surface. Oops, sorry, I need to do this one more time. Object I want to flow is my butterfly. Base surface, and the pink surface is my target surface. So if we come over here, you can see I've essentially put my butterfly onto my ring, onto my finger hole. So let's just delete out these meshes. I'm going to hide this. And now I can just start playing with my T-splines. I'm going to thicken it. I'm going to give it dimension. I'm going to use the command TS thicken. I'm going to thicken 1 millimeter. So now you can see I've created sort of a squished pipe almost. And I'm just going to start modifying. I'm going to delete these faces. I'm going to take this edge and this edge, and I'm going to pull it up 0.5 millimeters because it's still a little too shallow for me. So now it's a little rounder, it's a little chunkier. And the reason why I want it to be a T-splines is because I can now play. So say I wanted, the top portion to be a little bit taller than everything else. I can just come up here and I can pull it up. Say I could do the same for the bottom if I so choose. If I didn't like, the shape now that I'm in here, say I don't really like the shape, I can take some of these edges and pull them out and change the shape. I can even do things like broad modifications. I can use a command called cageEdit, which is a Rhino command, and you can get a bounding box, and I can pull these up if I wanted to change the shape. So all of these things are really helpful when you're not quite sure what you want your design to look like, and that's why I want to keep it a T-splines. So let me just get off this layer. I'm going to hit show, and as you can see, I already have created butterfly that I like. I've pulled, the edges and the faces, and I'm happy with how this looks. So now what I need to do is I need to connect it to my shank. I'm going to copy these and put them on the right layer, and that's going to be my butterfly ring. And now I'm going to convert these into a Rhino surface. So I'm going to select them, and I'm going to hit TS convert to Rhino surface. So now they're not modifiable anymore. If you see I turn on T-splines, there's no faces or edges to be able to select. Now I'm going to connect my butterfly the same way that I made my original ring shank. I'm going to use the profile of the open part of my butterfly with the bottom or the midsection of my shank. So let me just unlock my curve. And I'm going to create the profile from this open portion of my butterfly with the command duplicate border. So you can see I've created a closed curve from that open space. Now I'm going to use the same command I used before, sweep 1, and it's asking what's my rail. Here's my cross section, and here's my second cross section. Hit enter. Again, I just need to make sure that my seams match. Hit enter. And OK. Same thing over here. I have a rail, cross section, enter, and OK. So right now I have 5 separate poly surfaces, and I need to create them. I need to make them one. So I'm going to join them together. I'm going to select everything, and I'm going to hit join. Just want to make sure that it's on the right layer. And I'm going to turn off my curves. So now let's just check that it's closed. I'm going to go over here to what, and you can see it says closed poly surface. So now I know that this surface would be able to be printed if I wanted it to. Now the last thing I need to do is I just need to add my stones. I've already pulled in a stone and sized it to the size I want, which is 2 millimeters, and I've also created a profile curve for what I want my bezel to look like. So I'm going to make my bezel with a command called rail revolve. I'm going to hit rail revolve. It's asking, what do you want your profile curve to be? That's this. What do you want your rail curve to be? And that's basically the diameter of my diamond. And then what is your rail axis? And that's just the center of my stone. So I'm going to get a center snap and pull down straight away. And now you can see I have a bezel. Just going to put that bezel on its right layer. And the last thing I need to do is I just need to move these stones and place them where I want them to go. I'm going to turn off my rail curves and turn on, I've already made it for 0.5 millimeters. I'm just going to use my gumball and pull it straight up, pull it to where I want it to be. Then I'm going to come to my top view and pull this over and place it where I want. I'm going to copy it, copy my 2 millimeter to my other side. And that's really it. I just want to make sure that everything's touching. I'm going to select my bezels and my butterfly and use a command called intersect. And you can see it's created curves everywhere that it's touching, so I know that that's okay. Now the last thing is, it's actually, these bezels are too tall and I need them to be cut because this ring wouldn't actually fit me right now. It needs to follow, the bezels need to follow my finger hole. So I'm just going to use a command called Boolean split, and I'm going to split it with that target surface that I had created earlier. I'm going to hit Boolean split. I'm going to select all my bezels. Those are my surfaces I want to split. My cutting surface is my target surface, and hit enter. Now you can see I've cut out that portion, so now it follows my finger hole. So that's really it. Now I have a butterfly ring that I can prototype if necessary. So let's just get back in here. I'm just going to come in. So if I could leave you with anything, it's just a few tips that I have figured out with working with Rhino. First is work simply. The simpler your curves, the simpler your file, the easier your life will be. To that effect, rebuild when possible. The more that you rebuild, or when you rebuild very important aspects, the easier your life will be when you're doing more complex modeling later on. Maintain that clean file structure, and finally, reference the command bar, because if you're ever stuck, that is really what will help you. And then finally, practice. The more that you practice, the better you will get. And that's it for me.
Thanks, Debbie. That was awesome. I actually learned a few things from you that I sort of wish that I had come over to your desk at one point and asked you about. I didn't even realize that you could, in the drop down, that you could select tangency handles and delete them en masse. That probably would have saved me collectively like 50 hours of my of my time. So
yeah, that's definitely very helpful.
that was really good. Yeah, thank you. That was wonderful. I really appreciated you breaking that down in terms of workflow and best practices and the sort of like why and not just the how. Awesome. So we definitely have some questions here. I will just sort of start by reminding everyone that this tutorial, as well as the other ones in all of our Formlabs Comes to You series, is available on demand a few days after we're live. So definitely, if you would like to, if you missed the first part of it, I recommend coming back and checking that out. Or if you want to just follow along and practice with Debbie, this will be living forever with Formlabs. Yeah, so jumping right in. So there's quite a few questions. Brian points out just a bit about what we were talking about earlier around T-splines, sub-D. T-splines no longer being available, which you mentioned, but that the sub-D workflow is available in Rhino 7. I guess on that note, Debbie, maybe you could share a little bit if you've done any research at all into other sub-D softwares. I know that you haven't necessarily tried the Rhino 7 beta yet, but any other, you mentioned other sub-D plugins that could be potentially used with Rhino.
Yeah, sure. So I've tried a few. I haven't tried the Rhino 7 beta version. You have to have a Rhino 6 license, and I'm currently on Rhino 5 to be able to beta that. But I have seen the results of some of its modeling, and it looks very promising, which is exciting. Other software that's available, there is a software called Clayu, which offers sub-D for Rhino. I do have it. I'm just very comfortable with T-splines, which is why I've just continued to use it. And then there is another one, I believe it's called Sirius with an X. And I've tried it before, but truthfully, because T-splines is still working for me and it's not broken, I haven't really committed to using a different plugin, but
Yeah.
I know that anybody that's basically started in sub D post, I don't know what it was, 2015 or
Yeah.
16,
A few
whenever
years ago, I
whenever
think.
T-splines went away. So lots of people have been using different plugins for Rhino, and they've been working just fine.
Great, thank you. Yeah, and maybe just on that note, so you did mention that Modo, Maya, in terms of other sub-D softwares that are out
Yes.
there.
Mm-hmm.
Actually, there is a question about like how do you check dimensions, or how do you sort of verify dimensions? So maybe you could sort of talk to why you use Rhino in terms of dimensional accuracy, and how you deal with dimensional accuracy in T-splines and sub-D generally.
Sure. So with Rhino, you check dimensions. Let me just see if I can get out of
Yeah.
this. Um, you would check dimension with your drafting tools. So there's a bunch of different tools you can have. You can check a diameter, you can check a radius, you can check an angle. So you could come over, and if you have your right snaps on, which I do not, you could essentially snap to portions of your model and figure out the dimensions that way. And that's really great for creating, if you need to have sort of like a 2D image with dimensions on it to hand to a manufacturer, just so they know what they're making, anything like that. The drafting is really helpful, and to check with that. With T-splines, usually you can create T-splines around curves. So if you make sure that your curves are right and then check later, there might be a slight, it's sometimes like for a T-splines pipe, it might be a little bit smaller than exactly what a Rhino pipe is. But I
Yeah.
usually use T-splines for things that aren't, the precision doesn't need to be there.
Right. So like in this case, the butterfly, sort of the shape and the footprint of the butterfly didn't need to be, wasn't sort of dimensionally, no dimensional requirements, whereas the
Right,
shank obviously has to hit a certain ring size.
exactly.
Gotcha. Okay, thank you. Just in terms of sort of learning Rhino, are there any resources that you recommend to learn the different commands? What's the sort of like learning curve like generally for you, or that for a new user that you would kind of describe in learning Rhino?
Yeah, well, so there's a lot of great resources on LinkedIn Learning or on Lynda. I haven't particularly used them, but I know some coworkers that have used them and they found them incredibly helpful. I also took a refresher class. There's tons of classes out there that are available in your city that you can take. But truthfully, the number one way that I have learned to get better at Rhino is just to practice. You can go, there's the help bar up here that can help you with if you need to figure out a certain command or how it works. And then there's a lot of information online, a lot of demos out there on YouTube that are available for you to watch. But the more that you practice, the more comfortable you'll be with how the commands work. I honestly am still learning commands in Rhino. There's so much in here for you to learn. And so it's really just up to you to expose yourself to it.
And if you had to sort of ballpark guess how many commands you actually use on like a regular basis, is it
Uh,
tens, hundreds?
no, it's probably in the 10. It's like maybe between 50 and 100, I would say.
Yeah, yeah. And so, but there's probably, I mean, a lot more commands
Oh,
than
way
that.
more,
So
way
yeah,
more. Yeah,
yeah. And I think that's the key message there, is that with any CAD software, especially one that's more general use, like Rhino, not specifically for jewelry, you're going to find which of those 50 or so commands you're really comfortable with, and they become just really intuitive. Would you agree with
exactly.
that?
Yeah, like when I had the butterfly, the flat butterfly curves, I could have created it with a command called planar surf, which would have just made a surface out of my two curves, that was flat. But because I wanted it to be a T-splines, I use sweep 2. There are multiple commands for a lot of things that you need to do, and there isn't really a lot of times though a right answer. It just depends on what you're going to do next.
Gotcha. Yeah. And then there's so jumping into kind of prototyping, which I realize may not be totally directly your day to day.
Yeah.
Um, so there's a question about sort of tolerances. Let's see here. Yeah, I think this question might be more about accuracy or tolerances. Actually, let me just sort of skip over that and see if there's something that I can answer there. Oh, just some spelling of those names. So T-splines. Yeah, if you could maybe, so T-splines is T-S-P-L-I-N-E-S.
Yes,
However, not currently available for Rhino.
correct.
Well, as you said, mentioned Clayu,
Yep.
which is clay, so Clayoo. That one
Hmm.
is available. And
Yep.
then Sirius, you said, was another one?
Yes, that one is Xirius, I believe.
So
I just tried it once.
yeah, so Sirius with an X. And then other softwares that are specifically based in Sub D, so Modo, Modo,
Yep,
Maya, Maya, which those
correct.
are, I would say though, do you think that those are more advanced softwares to learn or just different?
Yeah. Well, I think they're a little more advanced. I haven't ever tried Maya. Maya is supposedly incredibly hard to learn. I do know Modo, and maybe it's just because I'm very comfortable with Rhino and I've learned it, but Modo seemed to be much more complex for me to learn than Rhino.
Gotcha. Great. And then there's someone brings up Grasshopper.
Yep.
Do you use that at work at all? Are you familiar with Grasshopper?
I am familiar with it. I don't use it very often because the nature of what I do oftentimes is it's so specific to the single piece that I'm doing that I don't really have a lot of definitions worked out that are useful to me. I could do it, quickly enough without Grasshopper, but I do know that a lot of people that prototype with, say they make rings all the time, different stone sizes, different widths, but they all have the same profile. For example, that having a grasshopper definition would be very helpful to them to get to it very quickly.
Great. Yeah, thank you. And then what about Rhino Gold? Someone's asking, have you used Rhino Gold?
I have in the past, I had Rhino Gold. Um, Truthfully, the best part about it for me was there was this command called move along surface. So when I placed stones or pave on my surface and I didn't like it exactly, I could move it quickly instead of starting over. That was the best part of Rhino Gold. I haven't used it in a few years though, but I know people like it.
I think the stone library was pretty cool too, to have all those pieces of
Yeah.
geometry ready for you. In terms of, so someone is asking about, do you do any sort of cost calculations? Have you explored any of that with CAD at all for jewelry, calculating costs?
Yeah, so when I worked at Temple St. Clair, I actually, a lot of what we did with designing was also, designing within a price point. And so a lot of times I would have to make sure that my model, I would analyze its metal weight, and I would analyze how many stones it had and plug it into, the system that they had and figure out how much the piece would cost and whether it would work within our budget.
Gotcha. Right. And so here's a question sort of jumping into prototyping, manufacturing, and I'll kind of answer some of these on the Formlab side. But maybe you could just speak a little bit to sort of best practices for manufacturing. I mean, I know you've had sort of different types of roles and probably some of them lended themselves to needing to create much more manufacturing or casting ready pieces, and others have been more visualizations. So can you maybe describe the difference between how you approach manufacturing ready versus visualization only?
Yeah, sure. Well, so part of understanding the difference between manufacturing and visualization, excuse me, is really to understand what happens during manufacturing, how they set stones, all of that stuff. Really keep that stuff in mind because it's going to dictate how you make your piece for manufacturing, and then also what it's supposed to look like in the end. If they can't actually polish that inside area and you are making it look polished, all of those things are definitely things that you need to take into consideration. So for manufacturing, I have never I've always only sent my file for manufacturing, and then they made the modifications for casting. So they would the manufacturer or the caster would, increase it to allow for shrinkage and things like that. But you just need to understand that those things will be happening. So
Right.
there's a lot of other aspects involved to take into consideration.
Great. Thank you. And then let's just see here. Just looking through these questions. Let's see. Lots of user support here, people providing guidance to each other, which is really cool. Um, let's see, so does Rhino have a function to prepare the model for SLA printing or printing formats? I can kind of answer that. So Debbie did a really nice job in describing how if you do want to prototype, you do want to print or fabricate, that you need to make sure that your model is watertight, meaning it's solid, so that there's no open surfaces that the printer can't understand. And so essentially, you can export a variety of formats from Rhino. There are some that are specific to Rhino, like 3DM. There are others that are more generic 3D formats, like STP or STEP files. 3D printing files tend to be STL or OBJ, and those are where you basically bake a mesh, a sort of polygonal mesh surface, and then that can be really read by most, the vast majority of 3D printing, 3D printers. And then there's also a question here about using a Formlabs printer for prototyping a ring. What strategy do you use to remove the resin from closed surfaces? I think this probably, the question maybe is around removing resin from those, like maybe the bezels, some of those very small details. I don't know that Debbie has a huge amount of experience with the printing side, so I'll just sort of speak to that. That's always a big challenge with any small model. Using a hand blower or compressed air is really nice, and trying to clear those areas out while you're finishing and rinsing your parts with isopropyl alcohol, using a pin or some kind of small device to kind of get in there and scrape out some of the excess resin. But that's really in very, very, very small cavities. And then let's see here. What else do we have for you, Debbie? I actually would love to ask you about, oh, here's one more question. So I think maybe, so you had sort of talked to SolidWorks versus Rhino. Maybe you could kind of just, again, sort of summarize the key sort of differences between SolidWorks versus Rhino, since they are both really old and prominent softwares.
Yeah, sure. SolidWorks is used a lot in industrial design. You essentially, I don't know a ton about it, so this is just my general understanding of it. You essentially have an object that you start with, and then you make modifications to it. You cut away at it. It's very structured. So how you start and the next steps that you make are very much, the software is dictating that. And then the difference with Rhino is that you could start anywhere, you can make any curve, you could create any surface and connect them together later. You don't have to start any in any certain way with Rhino.
Gotcha. Thank you. Just one question that I actually had for you as well from the very beginning of your presentation. I knew that you have a family of jewelers. I did not realize that you were a fifth generation jeweler. And I think you said your parents or a parent and grandparent both went to
Yeah.
GIA ahead of you.
Both
That's
my grandfathers on both sides, and my parents went there. They actually met there.
That's amazing. I mean, I don't really know if I have a question out of that so much. I guess Um, maybe a question is, it seems like jewelry is certainly in your DNA at this point, in your blood.
Yeah.
Is there what other things, what would you have done if not jewelry? Is there other is there other paths that you are interested in, and that now that you're into
Yeah.
3D CAD? I'm just curious on a personal note.
Well, truthfully, I didn't really know what I wanted to do post undergrad, and I took a little for granted that jewelry was in my blood. I wanted to get the degree to really learn a little more about it, but I had no intentions of being a part of the jewelry or the fashion industries. That really
Yeah.
wasn't part of my goal. I kind of wanted to be a doctor. Very different, I know.
Yeah.
But now that I'm in it and now that I've experienced so much about 3D, I really love prototyping in general and visualization, not just for jewelry. I think it's so interesting the way that you can take 3D and really implement it to show your designs, not just for creation, but if you just wanted to make a beautiful picture.
Yeah.
I love all aspects of it, really.
Yeah, no, very cool. Well, I think on that note, we will end. So again, this demo tutorial will be available on formlabs.com as all of our demos are saved. Thank you so much, Debbie, for being here and taking the time out of your schedule. Just again, really happy to sort of be able to give you this platform to share your wealth of knowledge and talent. And, hopefully we can do some kind of collaborative something again in the future. But I really appreciate it on behalf of all of the Formlabs family.
Oh, thank
Thank
you.
you
Thank you
so
very much
much.
for having me.
Of course. Okay, thank you all. We'll end it here. Have a great day.